everybody. Today we are discussing the representative element, the next chapter, representative element 2. So in the representative element 2, we are discussing the nitrogen family that is from 15th group till the noble gas. So the nitrogen family include the elements such as nitrogen, phosphorus, arsenic, antimony and bismuth, in which the phosphorus and nitrogen is a non-metal and arsenic and antimony is a metalloid. That means metalloid means it shows the property of both metal and non-metal, and bismuth is a metal. And as you know that the earth crust, the most abundant component of the earth atmosphere is the nitrogen. Now we are moving into the general characteristic of the 15th group. You know the most of the property, but even then I am fastly going into the some of the property. The first one is the electronic configuration. As you know that the electronic configuration of the nitrogen family is ns2 np3, and all the elements in the nitrogen family having the 5 electron in the outermost energy level. And next is the atomic size. As you know that the atomic size increases as we move from the top to the bottom, but when we moving into the nitrogen to the phosphorus, the size is there is a large increase in the size. But when we going into the heavy metals, that means heavy elements, that is arsenic, antimony and bismuth, there is a very short increase in the size. This is mainly due to the shielding effect of the p orbital in the phosphorus is very high. When we moving into the arsenic, antimony and bismuth, d orbitals is enter, and the screening effect or shielding effect of the d orbital is very less. So the influence of the nucleus in the outermost shell is approximately constant in this heavy elements. So that's why the atomic size is gradually increases from the arsenic, antimony and bismuth. So similarly the ionic radius. So next is the ionization energy. As you know that the ionization energy decreases down the group. This is mainly due to, in the case of the nitrogen, the electronic configuration, and that means the p orbital is half filled. So in order to emit or in order to remove an electron from their outermost shell is very difficult. So in the period itself, the nitrogen family shows the highest ionization energy. And in the case of the second ionization energy is less compared to the first ionization energy. And next we are moving into the electronegativity. So when we compare to the electronegativity, the nitrogen having the highest electronegativity, which is shown in the blue pillar, and in the case of the phosphorus it is little bit lesser, whereas in the case of the arsenic, antimony, bismuth, the increase is approximately, or electronegativity is approximately constant. This is mainly due to the screening effect of the d orbital. So the influence of the nucleus in the outermost shell is very high. So next is the metallic property. I already discussed the metallic property. The nitrogen and phosphorus is non-metal, arsenic and antimony is the metalloid, and bismuth is metal. So next one is the oxidation state. In the case of the nitrogen, the large variety of the oxidation state is available from positive +5, +4, +3, +2, +1, and similarly 0 and -1, -2 and -3. But whereas in the case of the phosphorus, this varieties is little bit decreased, and similarly in the arsenic, antimony and bismuth. So when we compare the positive oxidation state, the nitrogen shows the maximum positive oxidation state, that is from +1 to +5. But phosphorus, arsenic, antimony, bismuth shows the +3 oxidation state, and they have the reluctance to participate. The inner electron, s and p orbital, has an reluctance to participate in the chemical reaction. That's why the +5 oxidation state from the top to bottom, that is from the nitrogen to phosphorus, decreases gradually. This effect is known as inert pair effect. We have already discussed the inert pair effect. I am just mentioning the point, that is the inert pair effect. Okay. Now the nitrogen also shows the negative oxidation state and zero oxidation state. This is mainly due to the p orbital is half filled, so the nitrogen is stable, and the negative oxidation state is appear due to the by accepting the electron in the p orbital. While we are accepting the 3 electron, they are completed their all the p orbital in the nitrogen orbital, sorry, the p orbital in the nitrogen element is completed. So that's why nitrogen shows the negative oxidation state. As we move down, this the negative oxidation state is also decreases. And one of the speciality of the nitrogen is that nitrogen does not have any d orbital. So as a result, the availability for the bonding is decreases. Okay. Then allotropy. Allotropy, we have already discussed. The allotropy means it is the different form, existence of the different form of the same element. We have already discussed the allotropic form of the carbon. Similarly, nitrogen shows two allotropic form, alpha nitrogen and beta nitrogen. One alpha nitrogen is cubic and beta nitrogen is hexagon. And as we increase the temperature, this allotropic form is shifted. And phosphorus is also shows the allotropic form. 3 allotropic form is possible for the phosphorus, that is white phosphorus, red phosphorus and black phosphorus. Similarly, arsenic shows 3 different type of the allotrope, that is yellow arsenic, grey arsenic and black arsenic. And antimony also shows 2 different type of the allotrope, that is first one is yellow antimony, that is I am not showing the picture. Yellow arsenic, sorry, yellow antimony, that is we call it as alpha yellow. And the next one is gray, that is gray beta. Okay, gray beta is shown here. And next, the nitrogen, in our mind nitrogen is a gas, but instead of that nitrogen is also exist in the form of liquid. The last picture which is shown in the right hand side is the picture of the liquid nitrogen. And liquid nitrogen is having very low temperature, so that's why if you are keeping the liquid nitrogen in room temperature, definitely the nitrogen gas is evolved from this liquid, that is shown in the figure. So the temperature of the liquid nitrogen is very low, that's why we can keep the microorganism in the liquid nitrogen for preserving the liquid nitrogen, but it is very difficult. And liquid nitrogen is also used for keeping the low temperature, for getting the low temperature, for maintaining the low temperature we can use the liquid nitrogen. Thank you.